Let's determine if two switching circuits are equivalent. Two switching circuits are equivalent if they produce the same output for the same set of inputs. And I don't know about you, but sometimes it helps to think in terms of truth tables for me, because if I just look at these circuits, sometimes I have no idea. So let's determine if the following two switching circuits are equivalent. Now, we're going to assume that the inputs are P and Q for both. So we have the same inputs, right? Switching circuits are equivalent if for the same inputs, we have the same output. So if we're thinking in terms of like true or false, do they have the same truth value when they come out? Well, you might be looking at these and going, how am I supposed to know? Well, let's think through this. First, let's look at number one. P and Q are joined by OR. So P or Q. Then they come to the not. Okay, so not P or Q. Great. Now let's look at the second one. P goes to not, so not P. Q goes to not Q. And those are joined by and. Okay, so are these two equivalent? That's what we're looking for. Well, it's hard for me to just like jump. I mean, you might know something from a previous lesson. Maybe you don't. So let's look at our truth table. So I know that I'm comparing not P or Q to not P and not Q. Okay, and if you know this already, great, fast forward. If you don't, check it out. So I have a truth table of P and Q, meaning I have 4 lines, true, true, false, false, true, false, true, false. For P or Q, only one of these has to be true. So true, 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 false. Now to make that not P or Q, I take the opposite truth value, false, 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 true. And this is one thing I'm comparing, right? I'm comparing the two pieces. Now, to get to not P and not Q, I need the negations of P and Q. Well, the negation of P is just the opposite truth value, right? So if P is true, true, false, false, then not P is false, false, true, true. Not Q, similar thing. I just take the opposite truth value from Q. Now, not P and not Q means when I compare these two columns, they both have to be true. So false, 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 true. And when I compare, and I look at the two highlighted columns, I start with false, 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 true in both of them. So since they have the exact same truth value, that means yes, these are equivalent because they are both, well, they have the same truth value. So yes. Okay, let's do one more. So let's say we have P and Q again. So in the first one, P is not P or Q. And then down here we have P and not Q. Are these the same? Well, let's see what we've got. So we're looking at not P or Q compared to P and not Q. To do this, first thing we need to negate P. So again, opposite truth values. And we're using OR. So comparing, lost my pen, comparing not P or Q, as long as one of these is true, there's our line. Now we go to not Q. So false, true, and we're looking at P and not Q. That means they both have to be true. True, false, false, true, 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 false, 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 true. When I compare my highlighted lines, you'll notice true, false. Those are not the same. These are not equivalent because they do not produce the same output for the same input. So if you can't tell based on what you know, Create yourself a truth table and compare your lines. That will help you visually see whether or not they are logically equivalent.